Hi everybody, I'm leading Create Kotlin, and today I will tell you a story of K2 stabilization. And in fact, I have learned that not everybody is aware of what the K2 is, so we will really begin with what the K2 is, and I hope at some point our slides will work, so I will show you the whole agenda. But so far, we'll first talk about what the K2 is, then what are the quality goals posed by that, and in the end, I will explain how did we actually stabilize it. So, could you please let me show my presentation, please? Pretty please? Thank you. So, what the K2 is. First, let's do a little exercise. Who knows Kotlin? All right, good. Then probably it's not that huge that I have to explain what the K2 is. In fact, we have already talked about it. So what the K2 is? In fact, it's the same as Kotlin 2.0. You are probably all aware that Kotlin 2.0 is coming pretty soon. We have RC1 already released. And the K2 is the same thing, it's just a code name. But under the hood, do you know what does it mean? What do we mean when we say K2? Any ideas? No? Okay, good. What if I told you that it's just a refactoring? Everybody done refactoring in their lives, I believe. It happens that you are writing some code, and you're writing more, and then you are not quite happy with that because of architecture issues, because of some performance. So it's natural, you want to rewrite it. That's what we did. So I'm really having trouble with this clicker. Okay. So to explain what the K2 is, I'll go briefly, really on the high level, how does the compiler work and what did we do there? So this is a brief introduction. This is a picture from the Sveta Isakova's talk. She really explains a lot what the K2 is, and I'll do it briefly. So every compiler takes a source code as input and produces some target or machine code. It does some magic inside. We're looking deeper. Inside this compiler, in case of Kotlin, in case of the current stable version, K1, because we already have K2, so this is a K1, inside it consists of front-end part and back-end parts. So we can compile Kotlin to JVM backend, to JS, or native targets. So under the hood, it's a front-end. It takes Kotlin source files. It produces some syntax tree and passes some semantic information as well to the backends. Then the backends do their job, and we can run this code at JVM, JS native. All right. But some optimizations with those syntax tree information are common among all the backends. So why don't we just take it up and have this intermediate representation layer? Now we have a front end which works differently, at some point differently, and it passes some information, syntax tree and semantic info, to the common intermediate representation layer, and then we pass this information to the backends. This is how our K2 compiler looks like inside, at the high level. And well, we have rewritten half of a compiler. Now we get to stabilize it. Of course, we've got those advantages: better architecture, better performance, and in case of Kotlin, it's better language features in the future. Why? Because now we have a consistent logic among all the backends, and we have less of corner cases. So, at the same time, we wanted it to be the still good old Kotlin, because we're not like some other languages which release a new major version, which is completely different from the previous one. Instead, we wanted to release a new language version, which is as stable as before, but more performant one, the better one. So this is important now what the K2 is not. It's not a conceptually different thing. We are still the same Kotlin with all the same rules. And we don't want to bring any unbearable breaking changes to our users, to you. Right, now we know what we are testing. So what are the goals regarding the quality of it? As I said, we want the K2 be stable as much as K1, or even better, because we have written a new code that should be better in its architecture. And we also want to have a clear migration, because even with every major version of Kotlin, when we are fixing some bugs, we are introducing some changes, so the projects have to be migrated. Anyone migrated your projects to the new version of Kotlin, major version of Kotlin? Have you struggled with that? No? Yeah, I guess you all are using Kotlin 1.3. It's the most popular version now. Not now, but one of the most popular, because then we've got some changes there. Okay, so we also wanted to improve performance, and this is one of our quality goals. And we want those results to be persistent. So it's not that we have stabilized K2 at some point, and we are done, we are good, we are writing new features, we don't care about quality anymore. Instead, we want to set this bar, and after that, work on the results above this. So here is when the QA comes. So you have rewritten something, but then you come to QA and say, please stabilize it. Please tell us how to make it to have a quality for this. What do we do? Usually QA looks at what have we done, what we are going to stabilize, and then tries to structure it. So one of the magic things we do is set quality gates. This is the thing which would actually indicate us that we have achieved our goals, this is stable enough, and our users will be happy enough with that. Performance as the first goal, as the first gate, it should be there. And we also want the code to be still compilable, because in this case, we have rewritten a compiler, and we want it to work, still work, compiler compiles code. And also, it's important that we don't release the new version of Kotlin with the known issues which were actually reported to our U track, but we were not aware of those. And of course, it's a major version of language. We have taken care of some language design issues. And this is where QA comes really into play, because when you have complicated language design issues and you're changing something, you have to make sure that it works now better for all the users. So the most interesting part, how do we stabilize it? Performance, the easiest one actually, because from the day one we had those benchmarks based on IntelliJ community. I guess this is an instrument which is known by most of you. And next goes really huge part, the code compilation. We have rewritten our compiler. The simple thing, where do we begin? The new compiler have to compile hello world, right? This is the most simple thing we can imagine. So this is the hello world version of our compiler team. And we are talking about K2's journey. It began in 2018. The first person have started to writing some code. And in 2019, having already 20,000 lines of code written, we were finally able to compile the whole world with the new K2. The next thing is the nature one. You have some code, you want to compile more. Why don't you compile your own project? So we have this test as well. This is called bootstrap test, or bootstrapping of a compiler. So you take a K2 source code, you compile it with K1 compiler, which is the current stable Kotlin compiler. There is how we get K2 binary. Now we have K2 compiler. So we take the source code again, and we compile it with K2 compiler. We have K2 bootstrap compiler. This test has started to pass 2 years later, in 2021. And by this time, we had 86,000 lines of code to just be able to compile Kotlin projects. Next, we have tests. We all have tests, right? And this is a natural thing to rely on when you are doing some refactoring. Why don't we just take all the tests and migrate those to the K2, or run those with a new K2 compiler, watch results, compare those, fix, that's it, we're done, moving forward. The thing is that we have 280,000 of tests in compiler. And it's not likely that is the only specific thing about it. The thing is that compiler errors may be really different. So let's play a game, because I think it's too boring to just listen to me. Let's see what is the best bug, the worst bug you can meet with the compiler. I will give you some types of those bugs, and then we will do voting, but this kind of voting, so you do some physical work, because technologies. So the first type of the bug you may be able to meet with the compiler is that the compiler behavior is not consistent. You compile some code, then the same code doesn't compile, or it runs differently. This is the first type. The second type is that the very same code behaves differently on different backends. So, for example, on JVM it runs in one way, on JS it runs in the other way. The third type is called false negative, and it's an error reporting on a valid code. So you have written potentially valid code, but for some reason compiler thinks it isn't valid. You are freaked out. And the last one, false positive, that code is compiled successfully, and then it crashes in runtime. Right, so let's do this interview, because this is a question we ask our QAs when they apply to a compiler QA job. So, what is the worst error? Who thinks it's the first one? Okay, and it's like 10%, I guess. Second one? Okay, second one isn't popular at all, it's just a couple of people. The third one doesn't freak you out as well, okay. And the last one? Okay, this is quite popular as well, so we are between the first and the last one. The last one is the right answer. So, space shuttles. So, this is our hero, that the code isn't reported during the compilation, but then it crashes. And there are several flavors of it, actually. All the flavors are covered by the so-called diagnostic tests. They are specifically targeted on this error, and there are different ways of not working even there. So the diagnostic test, the diagnostic which should be reported by the compiler, is absent, and we are crashing during the compilation. But we also make a crash in runtime. We also report a different diagnostic with K2. Now imagine that you have thousands of tests, And yeah, all those types are different. And all this work got to be done. This is a screenshot of developer's report. Some developer has migrated all those tests and looked into all the results. And yeah, it has been a huge job. And by the 2022, we have been able to almost stabilize it, so we don't have such tricky errors anymore. By the time we had 122K lines of code. And this was JVM alpha release. Only JVM backend, no Kotlin multi-platform yet. So, moving forward, we have migrated our tests, our projects, we have compiled our board. What else could we do? We can take more code to compile. We have so many open source projects and our internal projects in JetBrains as well. So by that JVM alpha release, we have been already able to compile IntelliJ community source code and UTrack source code successfully with K2. And a year later, there were already 17 user projects successfully compiled. And this is the time where we have released JVM beta. And yeah, 140,000 lines of code. That time, we were able to compile IntelliJ Ultimate with K2, and this is really huge one. And I can tell that most of our user projects we were compiling was huge because the main interest for us was to cover the most of the use cases you may have when you migrate your projects to K2. So we have included some popular frameworks, popular technologies, to make sure that our new compiler works just as good as K1. Next, a year later, or not a year, actually half of a year, we have finally released a full beta of Kotlin 2.0, K2. And this means that now we were able to compile code not just for JVM backend, but also for native, for JS. You've seen we have rewritten quite a lot to make this happen. And we have successfully compiled 45 or 44 various user projects. And of course, the most natural candidate, if we are talking about Kotlin multi-platform, do you know what Kotlin multi-platform is? Okay, good. You're very well indicated. Thank you. So, you know, when we're talking about Kotlin multi-platform, it would be natural to compile first our own libraries. We've done this, and we have released the beta preview after all. We have also included by this time some Jetpack Compose related projects. I think it's also familiar to you. And now, just recently, we have released RC1, and by that time, we have counted 50 user projects compiled successfully. This includes Toolbox Enterprise. It's also one of the products of JetBrains. And also, we have added more Kotlin multi-platform related projects, as well as Compose multi-platform related projects. In fact, some user projects which were compiled before, we have just disabled Compose multi-platform modules for a while, and then we have turned those on again. And by this time, we have found 385 unique issues thanks specifically to those user projects, because this is real-world samples. We have compiled so many projects. We have minimized so many bugs. What else could we do to make sure that it works successfully? We are going to you, our users. So we have this group of EAP champions. You have probably seen this blog post a couple years ago. This is the EAP champions program, and it says that there is a group, a small closed group of people who work on a large-scale, real-life projects, based on Kotlin, of course, and they are ready to migrate our preview builds to make sure that it doesn't really break those projects, support us and they report us the issues. So we release the stable version, each stable version of Kotlin really stable. So it really helps us a lot with every single Kotlin release. So with the K2. This is just a screenshot of a section of our blog post for 1.9.20. And of course, when we have asked so many people to compile the user projects, we have also asked our partners to compile their code bases, the huge ones. But unfortunately, I'm not yet allowed to tell more about it. See you at the Kotlin keynote, you learn a lot of things there as well. Moving forward, we have passed a huge part of code compilation, so our compiler works now. But what about issues? We are getting issues reported in our open tracker. If you ever reported an issue to Kotlin, you've seen that. It's a KT project in utrack. And we don't want to release our stable Kotlin version with known issues. So we are taking care on every stage of this stabilization to make sure that we know all the issues which were reported. We have estimated those. We have assessed those and fixed all the major critical ones. And this is a chart updated just on the 19th of April. This shows a number of issues which were fixed, and those issues are unique for K2, specific to K2. And you can tell where we had those releases, alpha, beta, end of 2023, the full beta, and so on and so forth. Now it's almost 2,400 of fixed issues. And the last thing, now it gets a bit complicated in the end of the talk. This is the most crucial thing when we are talking about QA of a compiler or of a language. So there are some language design issues, of course, and we wanted the K2 2.0 to become even stabler and consistent language for you. So there are some huge language design issues. I'll talk about one specifically because it's an interesting story. Builder inference. Anyone have ever used builder inference annotation? Okay. So this builder inference annotation has been introduced in Kotlin 1.3 quite a while ago. And in fact, it would allow a lambda to be analyzed, annotated by this annotation lambda, to be analyzed as an expression. So we would be able to omit the type of returned expression. So our code becomes clearer. We don't have to specify the type every time. It's really good, useful. If you have liked it a lot, and we have also used it in our standard library in Kotlin, so by 1.6, we have introduced another function, build list, and it would use this builder inference annotation as well. And we have discovered that for some code, for some lambdas, it wouldn't still work. It wouldn't infer the type implicitly for us, even though it would be logical to use it there. So we have analyzed it and decided, why don't we relax our restrictions on the lambda's contents so such expressions would work as well? We have lifted those restrictions, and one more major release after that, we have decided, let's stabilize it after all. So many major releases have passed. We have such a good feedback for that. So why don't we just remove builder inference annotation? And it would work by default as is, without all the annotations. I have done it in 1.7, without realizing that before we had this control on what is analyzed in this way and what is analyzed in the other way. And oops, it turned out that this wasn't that harmless. Before we thought, if we would remove this annotation, we would allow all the users to profit from this smarter type inference for lambda expressions. And we would just turn a red code, previously not compilable code, to a compilable one. Everyone is happy. In fact, some code stopped to be turned out to be not compilable anymore. So the previously green code wouldn't compile, and this was a huge violation of our main principle that if we have explicitly specified type for expression, it shouldn't change anything, but it did. So on the one hand, a good code isn't compilable anymore. Why don't we just throw back the language version? On the other hand, we have had already some code in our own standard library, so we were affected, and we have realized that so many people will be affected as well. So, yeah, we have decided that we got to fix it a little bit in 1.7 versions just to not make it worse, and we'll fix it properly in 2.0. The problem is that now when we have lifted this annotation, this explicit sign that we have used the new smartest way to infer the type, we wouldn't be able to spot the problematic cases anymore. Neither in our code base or in our code base we would be able just to compile it, but on the external code bases we wouldn't be able to do that because it's not annotated in any way. So this is where the QA has come, because when we have such a situation, we get to analyze which exactly code can trigger such behavior, such in smart type inference, and then generate all the reasonable cases and check that it works properly there. You may look into this story of builder inference in those two listed issues. It was just the beginning of the huge fix. And in the end, we have now 172 issues related to this story. Most of those were created after this broke up in 1.7. And in K2, it's fixed. We have smarter type inference. Let's see if we have achieved all our quality goals. So, K2 got to be stable as K1. We have compiled so many different user projects, so much code, to make sure that every user scenario is covered now and works as good as before. And yeah, we have also made sure that this code still compiles, so we have good old Kotlin, but with a better performance. And during those migrations of 50 user projects, of course, we have catched so many bugs you would meet during your migration. So we have created this migration guide. You can either find it through the query code or through this link. And yeah, it has improved performance, but I wouldn't tell you how much exactly. And yeah, we've got persistent results because all those 50 user projects are now being compiled for every Kotlin build. And we see that it doesn't fail anymore. That's it. Thank you.
Thank you, Liliia. And now we can move to some questions. We have some questions in Slido. So first question is, will K1 be maintained after the K2 release?
Yeah, I mean, we still have those compatibility guarantees. And we are not going to release new versions of K1 because we believe that the K2 is very same but better. And it's backwards compatible just as the other previous versions or major versions of Kotlin. But yeah, I guess that's it.
Thank you. Another question, can you give us an example of an issue caught in a recent stage of the development?
Well, I believe that this type inference stage is more or less recent. I mean, this builder-included story. We have been stabilizing it for quite a while, and it got to be stabilized finally in beta 4, I guess. So yeah, so one of the type of the issues that you have your code with a immediate type, you have your lambda with an immediate type, and it's not analyzed properly in K1, but is analyzed properly in K2 now. Something like that.
Thank you. As a head of QA, what would you consider your biggest headache related to K2?
This is an interesting one. I think that actually it's not the biggest headache. It was the biggest effort to compile all those user projects. We have built this list more or less easily because we knew which exactly technologies are important and what should be covered. We also we are keeping an eye on all the open source projects more or less popular among our users. But you get to build 50 user projects you don't know. It's like, imagine you are coming into a new company and you have this huge project you have never seen before, and you are given a task to update it to the new version of Kotlin, to the new version of language. And you are updating it and you are struggling with it because this is a different setup, and it's different every time because it's built mostly with Gradle, and you can do the same configuration in so many ways with Gradle. And when you have finally achieved it, you have some errors, and you don't know it's you or not you. And then, after all, you have managed to build this project successfully. You have localized all the errors, so you don't just report an issue like this project doesn't compile. No, you are searching for those two specific lines of code which breaks the compiler. When you have so many modules in a project, it's hard. But then you go to the tests, because we have not just compiled the projects, we have also run all the tests for each of the projects. And that was really complicated. But we've done it.
Thank you. Nice answer. When can we expect stable release of K2? If you can comment on that.
You know, the hardest part is to not give any promises, because we are rather striving to make it as stable as possible. And if we discover anything which would take a couple of more days, but would instead bring us a better Kotlin, we would do it. So quite soon, but that's it. We have almost released RC2, so quite soon.
Quite soon works great. So you mentioned that you have 100K plus tests. Are they all manually written?
Yeah, at some point. It's actually 280, so it's almost 300K tests, but yeah.
Okay, and last minute question. How do you know there is no false positive tests in K2? How you can avoid them or recognize them?
Well, we have compared the results between K1 and K2, so at least if we didn't have those false positives in K1, we wouldn't have those in K2. But yeah, you can be sure with QA, you can be sure 100% in anything, never, just like never. You're just doing your best to make sure it's almost there.
Thanks, Liliia. Thanks for all the answers, and thank you for all the great questions. Liliia will move to the speakers corner when you can meet her and ask her more question in person. Now you can also rate this talk on Slido. There is a poll where you can rate the talk. And I have an announcement. If you ordered mdevcamp t-shirt, you can pick it up now near the Futured stand. So if you order t-shirt, you can pick it up. And that's all from me. We will have 10 minutes break now, and the next talk in this room will be Veronika Zelinkova, Swift UI means metal. Thank you.
Thank you.